Welcome to section 5.2. Just keep in mind when we're working on these, we cannot use inverse operations across the equal sign. So we can't do anything we can only work on the left-hand side or the right-hand side. So just pick a side and that's the one you want to work on. Now there's more than one way to do these. You want to make sure you have your trig identities with you. That way you're working on these and using that as your guide to help you through them. Now, like I said, there's more than one way to do it. So looking at problem number 1, we're going to verify the identity. I want to work on the left-hand side. So what I'm going to do is I'm looking at secant squared theta minus 1 over secant squared theta. So one of the ways we could do this is divide the numerator. So I'm going to split them up. So it's going to be the secant squared theta over the secant squared theta plus negative 1 over the secant squared of theta. So what's going to happen is the secant squared theta over the secant squared theta, that's going to become a 1. Now, looking at this, the negative 1 over the secant squared theta, or we can write that. Now, 1 over secant, that's the cosecant. So minus the cosecant squared of theta equals sine squared theta. Now, that looks pretty familiar. That looks like our Pythagorean identity that says sine squared theta plus cosine squared theta equals 1. Remember, our goal is to get sine by itself. So if I subtract the cosine squared of theta from both sides, I get sine squared theta equals 1 minus the cosine squared theta. So instead of writing 1 minus cosine squared, I can substitute sine squared theta in its place. And there we go, we just verified. We got sine squared theta equals sine squared theta. Problem number 2. I want to work on the left-hand side. Now, sine squared theta plus cosine squared theta, we just saw that. Sine squared theta plus cosine squared theta equals 1. That's a Pythagorean identity. So what we can do is we can do 1 over cosine squared theta times secant squared theta equals 1. So I substituted 1 in place of sine squared plus cosine squared. Now, looking at that denominator, secant squared is the same as 1 over cosine. So it's 1 over, now it's the cosine squared theta times, instead of writing secant, 1 over the cosine squared theta equals 1. Now if you look in that denominator, that's cosine squared over 1 times 1 over cosine squared. Those cosines cancel, so we're left with just 1 over 1. So 1 equals 1. We just verified that identity. Let's try another one. Now, when I see a problem like this, if you look, we're adding those fractions. We need a common denominator. Now, when I see this, I'm looking at 1 minus and 1 plus. Those are conjugates. When I see those conjugates, I want to multiply them by each other. So I'm going to multiply the first fraction by 1 plus sine theta over 1 plus sine theta. Multiply the second by 1 minus sine theta over 1 minus sine theta. So we get 1 plus sine theta over, and when I multiply those conjugates, I'm going to get 1 minus sine squared theta plus 1 minus sine theta over 1 minus sine squared theta equals 2 times the secant squared of theta. Now, these already have that common denominator, so we can combine them. So 1 minus sine squared theta is our denominator, and when we add 1 plus 1 is 2, sine theta plus negative sine theta, they cancel. So we're left with 2 over 1 minus sine squared theta equals 2 secant squared theta. 1 minus sine squared looks familiar. Remember, sine squared theta plus cosine squared theta equals 1. So if I get 1 and sine on the same side, if I subtract sine squared theta from both sides, I get cosine squared theta equals 1 minus the sine squared theta. So instead of writing 1 minus sine squared theta, I can substitute that with cosine squared theta. So it's 2 over the cosine squared of theta equals 2 secant squared theta. Now, 2 over the cosine squared, that is the same as 2 times 1 over cosine squared theta. And now 1 over cosine, that's the secant. That's that reciprocal identity. So it's 2 secant squared theta equals 2 secant squared theta. We just verified that identity. The key with these is making sure you have your identities with you and looking to see how can I get from the left-hand side equal the right-hand side. A problem like number 4. Looking at number 4, these look very familiar. If you remember our Pythagorean identities, 1 plus the tangent squared theta equals the secant squared of theta. And also, sine squared theta plus cosine squared theta equals 1. So 1 plus tangent, or tangent plus 1, that's the same as secant squared. In this case, it's an x. Cosine squared x minus 1. So if I rewrite this and I subtract the sine squared from both sides, and at the same time I'll do that in 2 steps. A little messy. So I get cosine squared theta equals 1 minus the sine squared theta. And I want to get cosine and 1 on the same side, so I subtract 1 from both sides. So cosine squared theta minus 1 equals the negative 1 times the sine squared of theta. So instead of writing cosine x minus 1, I can write negative 1 times the sine squared of x, that should be an x, equals negative tangent squared x. Now, secant squared of x, that's the same as 1 over the cosine squared of x, times negative 1 times the sine squared of x. I don't normally write the negative 1, but I'm going to do that in this case, just to kind of help us visualize. If you look now, you see we have the sine squared on top and the cosine on the bottom. So what we have here is negative 1 times sine squared of x over the cosine squared of x. And our goal is to get negative tangent squared of x. As we're looking, sine squared over cosine squared, that's negative 1 times the tangent squared of x, or negative tangent squared of x equals the negative tangent squared of x. There we go. We just verified that identity. Our goal is we kind of just want to keep looking at them and see how can we get from point A to point B. And these are a practice thing. The more you practice, the easier it gets. Let's try another one. Tangent of x plus cotangent of x equals secant of x cosecant of x. I'm going to work on the left-hand side again. So tangent is the same as sine over cosine. The reason I'm doing that is I know that secant is the same as 1 over the cosine, and cosecant's 1 over the sine. So I kind of want to know, I want to have sine and cosine in my answer. Cotangent is the same as cosine of x over the sine of x. Now, I want to get a common denominator. So I'm going to multiply the first fraction by sine x over the sine of x. The second fraction by cosine of x over the cosine of x. So what that gives me is sine squared x over sine x cosine of x plus cosine squared of x over the sine of x cosine of x. Now, as I'm looking at that, I add my two fractions. They have a common denominator, so I get sine squared x plus cosine squared x over sine of x cosine of x. Now, remember the Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. So instead of writing sine squared x plus cosine squared x, that's just 1 over the sine of x cosine of x. So really what we have here is 1 over the sine of x times 1 over the cosine of x. Now 1 over the sine, that is the cosecant. 1 over the cosine, that is the secant of x. I'm just going to go one more step here and just rewrite it in the same exact form. Because order doesn't matter for multiplication. Secant of x first times the cosecant of x equals the secant of x times the cosecant of x. And there we go. We just verified that identity. All right, let's go to the next page. Once again, I'm still going to work on that left-hand side. I'm going to rewrite secant of y as 1 over the cosine of y. And tangent is sine of y over the cosine of y. Like I said, these are tricky. We're just kind of getting used to rewriting. So now, I have a common denominator. I can add these fractions. 1 plus the sine of y over the cosine of y equals the cosine of y over 1 minus sine y. Now, I need to do some more rewriting. When I see something like 1 plus sine y, or I want to think about using the conjugate. So I'm going to multiply the top and the bottom by 1 minus the sine of y, 1 minus the sine of y. So in the numerator, when I multiply those conjugates, I get 1 minus sine squared y over, and when I distribute, actually I'm going to just keep it, I'm not even going to distribute, cosine y times 1 minus sine of y. And the reason I'm not distributing is because I already see I have a 1 minus sine y in my denominator on the right-hand side. 1 minus sine squared. That should be ringing some alarm bells. Remember our Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. So I want to get 1 and sine on the same side. So I'm going to subtract sine squared theta from both sides. Cosine squared theta equals 1 minus sine squared theta. So instead of writing 1 minus sine squared theta, I have cosine squared theta. So cosine squared theta over that should be a y. Cosine squared y over cosine y, 1 minus sine y. Now keep in mind, cosine squared, that's just cosine of y times the cosine of y. So if we have cosine squared divided by the cosine of y, what's going to happen is the cosine of y on top and the cosine of y on the bottom cancel. So we're left with, on the top in the numerator, a cosine of y over 1 minus sine y. That's exactly what we wanted. And there we go. We just verified that identity. All right. So like I said, it's going to take some more practice to work on these. I'll see you in the next video. We'll do some more. Have a nice night.